Alright guys, so I've been asked to do just a few example problems on this Name That Motion activity, so that's what this video is going to be. So I'm going to do descriptions B, D, and K. Just, pick those from that. And so the goal is to match these, descriptions with the graphs over here. And once you got that, here's the graph numbers right here, and you're just going to write the descriptions right inside. Make sure you write your explanation as well. Remember, you don't have to do the motion dot diagram, so don't worry about the motion dot diagram. Yeah, you don't have to do that part. All right, so the first thing, part B here says the car moves with a positive, in the positive direction with a negative acceleration. So something that's moving in the positive direction with a negative acceleration. So you can look at these graphs. Well, I can kind of see this, both of these are moving in the negative direction though, right? So once again, these are position time graphs. You always want to look at those. So to figure out how the direction it's moving, I need to find the velocity, because the velocity is the slope of a position time graph. I can use my tangent line to a curve, right? And all of these velocities, both this velocity and this velocity, is negative. I'm looking for something that moves in the positive direction with negative acceleration. So, okay, yeah. So this one's moving in the positive, this one's moving in the positive direction, but it's got a positive acceleration, as I'll find. The thing that's going to work for me here is graph 8 actually is going to work for B. So this one's going to work for B, and I'll show you why. So it's velocity versus time graph, and you can see this whole time, right? So velocity above this origin is a positive velocity, below this origin is a negative velocity. So the velocity this whole time is positive, but then the acceleration is negative. How do I get the acceleration? It's the slope of a velocity time graph. And I could see that this slope is going to give me a negative slope. So yeah, so 8 is matching with B, so that's what I would write. Let's just write it right here. B. That's what I'm saying. All right, let's go to D. D says the car moves with a constant negative velocity. Then the car remains at rest for several seconds. And finally, the car moves with a positive acceleration. So at first, it's got to have a constant negative velocity. Well, let's see, which one of these has a constant? This, let's see, this is a position time graph. That's a positive velocity, though. This is a positive velocity. It can't be that. So it's got to be a constant negative. Well, here's a constant negative velocity, but it's negative the whole time. So, ooh, graph 2 looks, here we go, constant negative velocity. Then it stops. And then at the end here, we get a positive acceleration, because this is a velocity versus time graph. And how do you get the acceleration of velocity time graph? It's the slope, and that is a positive slope. So this, I'm going to say, is D. So graph 2 matches with D. That's what I'm going to say. All right, and then lastly, I'll do K. So I think I got this one. I think I got this one. Well, yeah. So next I'll do K, which is the car moves with a low speed for a short time interval. So it's speed, so it could be positive or negative velocity. Okay. Then the car remains at rest for several seconds. So again, we're doing that rest thing. And then finally, it rapidly accelerates with positive acceleration. So I could go through and mull through a lot of these things, but where I'm best going to get is actually graph 10 fits best. So a lot of these graphs you'll be like, ooh, this fits, this fits, this fits, but then some of them are, it's very subtle, and that's what's good about this activity is you have to really pick out the correct motions here. So some of them you might think like, oh, it could be this one or this one, and you'll have to eliminate it by basically picking apart the details. But yeah, graph 10 is going to end up working best here. So this one I'm saying is going to be with K, because it's a position time graph. So to get the velocity, it's going to be the slope, right? And that is a low speed for a short time interval. So that's a low speed for a short time interval. And then it remains at rest. So then it's at rest. So that's that part. So time interval. And then lastly, rapidly accelerates with positive acceleration. And so we see this curvature right here, and that's the curvature associated with a positive acceleration of speeding up, because we start with a low velocity, doing that tangent line to the curve, and then we get a high positive slope like that. So and that means it's if I did a velocity time graph of this, at this part I would be at a low velocity, and then it becomes high positive velocity, and the slope of velocity time graph gives me acceleration, and that slope is a positive slope, so that's a positive acceleration, which matches that graph there. So I'm going to say 10 matches with k. So, and then lastly, I would write down then all the explanations as to what I just said to you is kind of what you would write in there for your explanations. So hopefully that helped. All right. Take care. Bye.